Hello, everybody. Today, in our class of Science and Technology, we are going to start reviewing some concepts of energy and forms of energy. So, remember that we have said that energy is what causes change, is the ability or the capacity of a body to produce a change. Now, there are different forms of energy which are mainly divided into kinetic energy and potential energy. When we say kinetic energy, we are referring to movement. Movement is equal to kinetic energy. Most of the things that we use are moving because of electric energy. Remember that electric is related to the charges that we have studied previously, and we have positive and negative charges. There are the electrons in the atoms, so those are also related with the electricity or the electric energy that we have and that are causing motion or movement. In addition, we have potential energy. Potential energy can be divided or classified or has three different forms. The first one is gravitational potential energy. That is the energy that has an object that is not on the surface of the earth, not on the floor. Maybe something that we have on the shelf and a higher and on the table. We may have objects, and those objects contain potential gravitational energy. Why? Because they are being pulled down by the gravity force. Okay, so they may fall down into the floor because of the action of gravity. The nuclear energy is the energy that is contained in the nucleus of the atoms. We process nuclear energy in special plants that release the energy that is contained in the nucleus of the atoms that we know that are made of protons and neutrons. The elements that they use in the nuclear plants to release the energy are of a specific elements. For example, uranium. That is one of the elements that they use in nuclear plants in order to release the energy and transform it in or electricity. Another form of potential energy that we have is chemical energy. Chemical energy is stored in different things that we consume. Example, we need food to live, and the food contain different forms of chemical energy. We refer to the chemical energy because it is the mixture of different atoms that make substances or compounds that are going to be providing the energy for our body to work. Okay, so those are basically the main classification of energy. Now, there is another that is a form of energy that is mechanical energy. Mechanical energy is the sum of kinetic and potential energy that an object have. Okay, so mechanical energy is when we have an object that has the capacity of making a change or causing a change, but also that has the kinetic or the movement. For example, a windmill. A windmill is something that we have that is on the earth, is something that we have that is high on the air. So we have something like this, and here it has some things that are going to be moving by the action of the wind. Okay, so it has kinetic energy and this, but also has gravitational energy because it is high in the air and there is a gravity force acting over it. Okay, just to show you a little how it would be the mechanical energy working. but there are more forms of energy. We also have the, thermal energy. So when we are talking about the thermal energy, thermal means heat is related with temperature. Okay, so thermal is related with temperature, and it says that is the sum of the kinetic energy and the potential energy. But in this case, it's not the the one that is contained by the object, but the particles that make up the object. Okay, so every object is made of small particles are organized inside of it. Those particles have some kinetic energy because the particles are always in constant movement. When we have a solid, the movement is not too much as if it happens in liquids or in gases, but the particles are always in constant movement. That is why it has kinetic energy. And there is also some potential energy because each of the molecules or the particles that we have are made of a nucleus that is positive, and around it we have electrons that are negative. So the negative and the positive charges of each of the atoms that we have inside are they have some potential energy. They have the capacity to attract each other. Okay, so this is when we're talking about thermal energy, we are talking about the particles, the energy that have the particles of the object. And when we're talking about mechanical energy, is when we are referring to uh, the kinetic energy that has the object. Okay, so the big difference between these two, as it says here in the exercise one, is that the mechanical is in macro. We were talking about big objects. And in thermal energy, we're talking about the small particles that are making up the object. Okay. There is another form of energy that is carried by waves. Okay. The first thing that we need to have clear is what is a wave. So here in the image that you have, you can see some of the waves on the ocean. And it says that the wave is a disturbance, a movement that transfer energy from one place to another. But it is not transferring matter. The only thing that is transferring is the energy. And remember that the energy has the capacity to cause a change. Okay? So the sound energy is one example of a type of energy that is moving or that is carried by waves. Okay, the sound is traveling from particle to particle, and if we want to see an example of that, we can think on the falling dominoes. Okay, when we organize dominoes and we stand them and like in line like this, and we make them fall, one is going to hit the other, and that is going to hit the other. That is how the sound energy is traveling. Some of the examples of how travel the sound energy are possible to see in these images. Okay, here we can see the waves that are taking the sound. This is an example of a movie of X-Men, and these are the waves of the sound, how they travel in the air. Okay, another example is about the bats. Birds are animals that are kind of blind, but they have a bad sonar. Okay, but bad sonar means that they produce a sound, and that sound travels on the waves of the air. And when they find an object, in this case their prey, the sound bounces on the object or on the animal and returns the sound waves that is perceived by the bats with their earrings, so they can easily identify if there is any object, a food, animal, or obstacle in their way, because as you know, bats also move in the middle of the night. Okay, so this is a little representation of how the sound energy works and travels carried by waves. Now We have the radiant energy, and we have that the energy is carried by electromagnetic waves, and that is radiant energy. Electromagnetic waves means that electro has to do with electricity, and magnetic with the opposite charges that are appealing each other. Okay. It also says that the electromagnetic waves they are perpendicularly to one another. This drawing that we have here is the representation of perpendicularly. In addition, it says that the electromagnetic waves travel through matter and through spaces that have little or have no matter. There is something that we call vacuum, the vacuum as in Spanish vacío, and the light can travel in vacuum because it is an electromagnetic wave that it is using to travel, and it says that it can travel in little or no matter. Now, to understand a little of this, so we have the wavelengths. It says that the wavelength is the distance from one point or on a way to the nearest point, just like it. So here we have a representation of the electromagnetic waves, okay? The red line is representing the the electric fields, and the blue line that is coming into the front and into backwards is representing the magnetic fields. So remember, this means that they are perpendicularly, so this is the movement of them. Okay, some of them are moving just in this line here, and the other ones are moving in this way. Okay. The length of the electromagnetic waves is coming from the highest point of this wave to I'm sorry, from the beginning of this wave to the end of it. Okay, so that is the length of electromagnetic waves. Why is it important to know this? Because this has relation with the the electromagnetic or the energy that we can see. Okay, here we have this an image that is presenting a lot of things. Okay, the first thing that it says, if it penetrates our atmosphere, so the radio, when we call it radio, they penetrate the earth atmosphere, but there are some others that don't. Okay, so this white and black line that we have here is trying to classify which of those waves can be penetrating the our atmosphere. The wavelength is something that we have listened a lot, and we have radio waves. Okay, and this is a unit that it is representing the length, how big they are. The microwave, the one that we use, and devices in the kitchen. Infrared is also something that we have seen. There is only few of the energy that is transferred through electromagnetic waves that we can see. Okay, that is why it says visible, and we see them in these colors that we have here that we call the arcoiris or the rainbow. Okay, so just the energy that is traveling in the waves that are this big are the visible uh, energy that we have and the different colors that we have. Okay, how big is this? Well, as big as a protozoan. Okay, that is the size of it. But there are some other like energy that is transferred, like ultraviolet, X-ray, and gamma ray, that the size of the wave is as small as a molecule or as an atom, so it is not something that we can see, but that we use every day. I hope this video has been really useful for you. Thanks for watching. Till the next time.